Hello everyone, this is Dr. Mahmoud Al-Odeh, another video of quality assurance, and we will be talking about the normal curve and the z-scores. And also we'll be talking about how we could find probabilities through the normal curve. Let's go ahead and start. And the first thing that we need to do is take a look into the goals for this video. We'll be talking about the characteristic of the normal curve, including the mean, the normal distribution. Also, we'll be talking about the area under the curve. Number four, we'll be talking about how we calculate the z-scores. And last thing, we need to end up with probabilities. All right, so the normal curve, an extension for the histogram. We did talk about the histogram, and part of the histogram is to organize the data into categories. So for example, in this chart, you will see category number one start from 0 to 5, then from 5 to 10, then 10 to 20, etc. So what we did here, we look into the observation, we track the observation on a check sheet, and we then organize these occurrences in categories. And what it is important to look into the histogram and fit the normal curve under it. So this line right here called the normal curve, it's also called the bell curve because it looks like a bell here, as you see. So why this is important? Because we need to study the data if it's normal or not. So if it's not normal data, if there's too many extreme values, that will not give you a good indication. So it is part of you as a quality manager and quality engineer. You need to ensure that you have a good measurement before you do anything, before you do any analysis in the Six Sigma. You need to make sure that when you collect the data, you collect a good data, a valid data. However, if the first thing that you want to do is to test the normality of the data. Do you have an extreme values in the data? If there is an outliers, which is basically the values that has a very high value or a low value that will change the mean and the average of the data, these should be taken off. So the first thing they want to do is test the normality of the data. And if you are able to fit the normal curve, this line here, the black line, if you are able to fit that line under the curve, that means you're good. You can you have a normal data, and the data is distributed normally. Somebody will say, well, how about this one right here? Yes, it looks like there is an extreme value here for some reason, numbers of hours. This chart is for number of hours worked last week. There's something not right in this data. So this is, even we have some extreme here, we still have the normal curve fit nicely. And how we could say it fits nicely, if you divide that into two half, you will have the right side will be a mirror for the left side. We'll talk about the more characteristic of the normal curve, but for now I want to let you know from this slide that it is based on the histogram. And once you create the histogram, you fit the normal curve and see if that's look nice. If How do you know if it's look nice? If most of the data clustered under the bell curve here. If you see the symmetrical shape of the normal curve, that means your data is normal. We'll talk about it in more details. Yeah. So normal curve is basically divided into areas, and there are uh, areas on the right side. These are the positive, and areas on the left side. These are the negative. The mean here, it's the number 0. So that's a 0, which means that your target, you are targeting for all your data, you're targeting the mean. So you need your data to be you need your data to be around the mean. So you need your data to be here, here, as close as you can to the mean. What does that mean? We be able to satisfy the customer. So that's the customer. What the customer wants is right here. So once you provide the data with what they need, this is the target. The more you go away from the target, the more the customer will be unhappy. However, there could be some specification limits, tolerances. And it said, okay, if you give me data here, that would be okay. If you give me a part that with a length here this far from the mean, that's okay. We still have some room to um, uh, to make sure that the data will fit, or the part will fit, or the customer will be served, etc. So what I'm going to say, it's divided into two areas. One is on the right side. These are the positive. These are the positive on the right and negative on the left side. The mean is in the middle. 50% of the data located on the right side, 50% of the data located on the left side. So what does that mean? That means the data, all the data should be 100% under the curve. All your data should be under the curve. And now, in order to find the exact position for a value, we divided this into a one standard deviation. So that's plus one standard deviation. This is plus two standard deviation, plus three standard deviation, etc. Same thing on the negative side, on the left side, negative one standard deviation, negative two standard deviation, negative three standard deviation. And why is that important? Because we need to locate the data. So if I said this measurement is located at a negative two standard deviation, I would know that this data located here. If I say the data is located at a positive three standard deviation, I would know exactly the position for that point to be here. If I say the data is on the mean, it's right here. So we did use these areas. So we have on this chart 1, 2, 3, 4 on the left and another 4 on the right. We use these areas to identify where the position of a particular piece of data. And the data should be 100% under the curve, 50% on the right, 50% on the left. However, if we say what would be the data between the plus one standard deviation and negative one. So what's the data? What's the what percentage of data? What percentage of data located between one standard deviation and minus one standard deviation? And that would be this area right here. So that's between this line and this line. So that would be the between the one standard deviation and a negative standard deviation. And that should be 68.268%. So 68% of the data located under the 1 plus 1, plus 1 and plus 1 minus 1 standard deviation. So these should be not outside. So just we need to make sure that the data between one standard deviation and minus one standard deviation. So here, now if I said, how about the data between two standard deviation and negative two standard deviation, that would be the data between this line and this line. And as you see here, that would be 95% of the data located in between these two standard deviation, plus minus two standard deviation. And that would be, I'm going to use a different color here. So that would be the green side here. And this here as well, in additional to the blue side. And the same thing for the three standard deviation, that would be 99%, etc. We'll talk about in more details, but I want to tell you that 100% of the data located under the curve, the normal curve is divided into areas, and these areas 50% on the right side, 50% on the left side. And we also talk about the data between one standard deviation and minus one standard deviation, that would be 68%. And between plus and minus two standard deviation, that would be 95%. And also you could do plus 3 minus 3 standard deviation, that would be also 99%. All right, let's take a look into more details. Why we use the normal curve? What's the characteristic? What is the normal curve? The normal curve, basically, it's a theoretical construction. So it is based on theories. They could be, there's no way that you have 100% normal distribution, which means 100% symmetrical bell curve. But however, we try to fit the data in there. Example, the chart that I showed to you in the first right here. Okay, here's the example. So what we tried to put the normal curve. So it is a theoretical based. It is based on theory, and this could be called the Bill curve as well. And perfectly symmetrical normal distribution. So it is. This is what we assume. This is what the theory is. It is perfectly symmetrical, and this is where the theory comes. When you apply it in real life, it does not give you a perfect symmetrical, but close to symmetrical, as the example that I shared with you. One important thing that you want to know, that the mean of the distribution is the midpoint of the curve. So if you look into the mean, that would be the middle line in the midpoint of the curve. That would be, it is important to know that that's the mean, because all your calculation will be based on that mean and how far you are from the mean, how many standard deviation you are away from the mean, how many sigma you are away. And again, sigma is another name for standard deviation. The tail of the curve are infinite, so that could be goes on for infinity. So that's why we're saying sometimes it's theory, sometimes it's not. Does represent the real life, but not as the theory mentioned. So it is infinite tails for it. The median equal to the mode that's in the normal curve. Whenever we have a normal curve, we should have the mean equal to the median equal to the mode. And the area under the curve is measured in standard deviation from the mean. How far you from the mean? One standard deviation, or 1 sigma, 2 sigma, 3 sigma, or 1 - 1 sigma, -2 sigma, -3 sigma, or -1 standard deviation, -2 standard deviation, -3 standard deviation. All right, going back to that, if we have a normal curve, the mean is equal to 0. That's for the theoretical part of the normal curve. Whenever you have normal curve like this one, start from 0, 1, 2, 3. That means the mean is equal to 0. So that's the mean. That's the mean right here. This line, we did talk about it. The middle line is your target. That's the mean, and the standard deviation is 1. So this is a 1 standard deviation, 2 standard deviation, 3 standard deviation, etc. The area between 1 standard deviation and between 1 + 1 and -1 standard deviation, that would be 68. This area right here between these two lines. The area between 2 + 2 - 2 standard deviation, that would be 95%. That would be the blue area here. So that would be including the blue area and the green area together between this line, as you see, this line from here to here, that would be 95% of the data located in here. And between ±3 standard deviation, that would be 99.72%, which means the 99.72% of the data located in under or between plus minus 3 standard deviation. So the green, the blue, the red on both sides. So all that would leave you with a teeny tiny data distributed in here and could be goes infinity. So what we've learned that the mean is here in the normal curve. The mean is equal to 0. The standard deviation is equal to 1, and we've learned 68, 95, 99 rule. Keep that in mind. And that could be go to 99.997 for the 6 sigma. All right, so what's the difference between 3 sigma and 6 sigma? The difference between a 3 standard deviation and a 3 sigma, 3 sigma and 6 sigma. This is and we did talk about it in a previous video, but this is the 3 sigma is a wider, this distribution of that curve is wider, which means there is a lot of variation in your process. And see, the variation goes from here all the way to here. If you measure this line, that would be the standard deviation. That would be the sigma, or what we call the standard deviation. So your goal is to reduce the standard deviation, to reduce the variation. And that would be the 6 sigma curve, because you have a high peak. The data is clustered around the mean right here. The data should be around the mean. Right. All right. So again, this is the difference between 3 sigma and 6 sigma is the variation. The 3 sigma has a high variation. 6 sigma is less variation, where the data is clustered. So this the variation is between these two lines, and that would be, as you see, if you measure this line from here to here, would be smaller than the line from here to here. All right, now we're getting into, now we learn about the normal curve and the characteristic of the normal curve. Now let's talk about the z-scores. What are the z-score? These are the technique that we use to determine the position of a single score under the normal curve. Again, if we have a normal curve and we need to find a score, specific score, where's the position of that score, we could find it on the normal curve. So if somebody took an exam and that person achieved 99% in the exam, we need to 99%. We need to know if he's among the majority, is he's one of the top 10, or if he's one of the or below the average. It could be everybody in the class achieved 100% except that person, which means that he's below the average or she's below the average. If somebody achieved a 60 out of 100, we need to know if that's a normal curve. They could be achieving 60 out of 100, and he's one of the top 5 based on the score. So the z-score will tell you the position of the single score under the normal curve, measured in standard deviation relative to the mean of the curve. So as we know, the normal distribution, we organize it within areas: 1 sigma, 2 sigma, 3 sigma. On the right side and the left side would be the negative sigmas. And this is where the standard deviation, we use the standard deviation, these sigmas, and the mean to know exactly where the position of that point. The z-score can be used to determine an area under the curve known as probability. Excellent. So that would be the chances of getting the top 10%, or the chances of getting above average, or the chances of receiving X score. So we need to look into that in more details. The equation to find the z-score would be x minus x bar, which is the average, divided by the sigma, the standard deviation. All right, going back to the curve, just a reminder that the total area under the curve is 100%, 100%, or 1. So now from here, that's the mean. Here to here would be 50%. And from here to here would be another 50%. So 50% on the right, 50% on the left. And we start looking into the area. So if I said, so you start from here, this is 0, this is 50% of the data. That's a 50% of the data on the middle here. If we came here, that would be 100% of the data located in under the curve. Just a quick question. If I said, where's the 10% of the data? That would be, maybe you say, here's the 10%. Just a rough estimate. This is not accurate, but that's going to give you an idea on where is the 10%. If I said, where's the 45%? The 45% would be somewhere in here, and say, okay, here's the 45%. 45%. And now if we said, where's the 60%? We say, okay, well, here's the 50, and this could be somewhere here. Again, these are just estimates, but these are very helpful because it's going to tell you what's the position of a specific data on the curve. If I said, where's the 80%? That would be maybe here. That's an 80%. So an idea, and this is important. Yes, this is a rough estimate, but it's important because we need to know how we could divide the normal curve. This is the 50% line. Below that would be the 0, 10 to 50. And from here, from 50 to 100, that would be the 100% of the data located. Again, the total area under the curve would be 100% or equal to 1. All right, so let's test our knowledge here. Example number 1, we have this curve, normal curve, and this normal curve, and we're trying to find the greater mean. From our understanding for the normal curve, we say the mean is the middle line of the curve. So we create a middle line here, and that would give you the value of 15 for A. And for B, we say, all right, here's the normal curve, here's the midline, that would be 12. So which one is bigger, which one is higher, 12 or 15? So 15 is the higher. A has the greater mean. Uh, Now moving into another question. So if we said which one has a greater standard deviation, which means which one has a variety mean, the more flatter one would be the one. But we said the standard deviation is the spread of the data. And this is the standard deviation for A, and this is the standard deviation. This is sigma here. I did write sigma, and this is the standard deviation for B from here, from this point to this point, and that would be the sigma. And we look into this sigma versus sigma. This would be a bigger sigma, bigger standard deviation, bigger variation. So B has a greater deviation, standard deviation. Excellent, excellent. Now let's take a look into how we could calculate the normal curve. In order to calculate the normal curve, what you need to do, keep in mind the z-score equation, z equal to the x value, the value, the point, minus the x average divided by the sigma, the standard deviation. So the first thing that you want to do is I want to let you know that you need to use appendix. You use the table, the z-score appendix for the normal curve, and these exist in any textbook. So for example, in my textbook that I have, it's an appendix A or appendix 1, and we will have to use that. If you, I think you can do it online. I'm going to take a look in. I'm going to take a look in to see if there's any website that I could share with you here in just a second. All right, guys. So I did find you a source just to let you know. I'll be sharing with you in just a second. So what is the z-score? It's a technique that we use it to find the position of the point of a single point on the normal curve. What we need to do, we need to use the z equation, x minus x average, or the mean of the data divided by the sigma. So the first thing that you want to do is by using this equation, we will be able to convert the raw score. We will be converting the raw score into a standardized score. As mentioned, Appendix A in most of the books, or Appendix 1 in my textbook here, would give you the data. Once you find the z-score, you go and look at it, and you find the percentage under the curve. We need to make a rough sketch of the normal curve and shade the area in which you are interested. In order to do this, let's take an example to demonstrate this. All right, here's an example. Find the area under the standard normal curve to the right of 0.87. So now the nice thing about this example, they already give us the z-score. This is the z-score already given to us, is to be 8.87. So we don't want to find the z-score, because it is a standardized score. So there's no need to find the standardized score. It is not a row, it is a standardized score. It's a z value. So to the right of it. So what we need to do, we need to find the area to the right of 0.87. So here's 0.87. Again, how did I find this? This is 0.5. This is the 50%. All right, this is the 50%. This line, the mean, the 50%. And this is 60 maybe, this is 70, and this is 80 and 87. So it's a rough estimate. Again, that does not need to be accurate, but you need to understand what area you're looking for. So we're looking into, if this is again 0.5, we're looking to the right of 0.5, this is 0.87, and we're highlighted this area. So the first thing that I want to do is create the normal curve, put the mean, here's the mean, that's the 50% line, and or 0.05. All right, and now we're looking into 0.87. That would be somewhere, would be here, 0.87. And you highlight this area. So you highlight this area. So similar to this one here. So I apologize for, it's hard to write with the mouse here, but I hope you guys get the point, which is you, first of all, you create the normal curve. You'll say this is the normal, this is the mean, which is 0.05 of the data located on the left side and 0.5 located on the right side. We're looking into 0.87. 0.87 is located in here. So we need to find out what would be the area. All right, so next, what we need to do, we highlighted, we know this is what we want. So the next step is to go to the to the Z table score, and to the Z table score, and I found a website called Z table, which I will be sharing with you here just a second. So I'm going to share here this one. So this is the website that you could use if you don't have a textbook or a reference, but these are very common, known in the industry. You could find it anywhere, but if you want to look at it online, that would be the Z table. There are many other resources as well. So the standard score, the Z score is 87. So there's two tables, one for the negative standard deviation or and negative Z scores and a positive Z scores. So for this one, for this example 0.87, we need to go to the positive one. So that would be right here. So you go to the 0.8, that the column, and on the that's for the row, and for the columns you go to 0.07, and the intersection between the column and the row would be 0.8078. 0.8078. I'm going to write this down here. 0.8 7 0.8078. Okay, so the first of all, what we did, just a reminder, we did created the normal curve. We highlighted the area that we are interested in. We went to the Z-score table, the positive one, and we found that's value to be 0.8078. And let's take a closer look into that table. Okay, the table should look like this one. We look into the row of the 0.8 and the column of 0.07. This is the value that we're looking for, 0.8078. And now what does that mean? That mean the area from here to here, because we're calculating the area under the curve. So the area from here to here to be 8.8078, 80% of the data located from here to here, and the rest of it is from here to here. So what is the rest? If we know that the all area is 100%, so we know that 80.78 is on the left side of the Z-score of 0.87, and now we need to find out what would be the area. That would be 100% minus the 80.78, and that would give you a 19.2%, which means that 19% of the data located on the right side of the Z-score of 87. All right, another example, just to make sure that you understand it correctly, find the area between under the standard normal curve between 2 and 3. So again, we created the normal curve, we sketch it. That's a 0, 1, 2, 3. So we're trying to find the area between 2 and 3. The first thing that you want to do, you go to the Z-score table and find what would be the area under the 2. So from here to here would be, if you look into the table, you will find a value of 0.97. So 9772, which means 97% of the data, 0.72, located on the left of the two standard deviation. And if you go to the area under the curve for the 3, z-score 3, that would be the 9987. 9987%. Now, what we're trying to do is trying to find the area. So if the area from here to here is 97.72, and the area from here all the way down be 99.78. So the difference between that will give you the area. So we have to subtract 99.87 minus 97.9772. That will give you 0.0215. Again, what we did, we're trying to find the area between 2 and 3. You go to the z table and you find what would be the area under the curve under the 2, and that would be the value of 97.72. You go to the other value 3, which is to be 99.87, and now you subtract it from each other to find the area to be 2.15%. So only 2% of the data located between 2 standard deviation and 3 standard deviation. Another example and practical example, and this example we will calculate the z-score because this is giving us a raw data, raw scores. So let's take a look. The weight of 10-year-old girls are known to be normal. So this is the first thing that all our assumptions should be based on a normality. So we know this is normal. The data is normal. Mean is to be 70. And standard deviation to be 13. Obtain the percentage of the 10-year-old girls with a weight between 60 and 90. All right, awesome. So the first thing that you want to do is find draw a sketch, a normal curve. Okay, so we have the normal curve right here, and we know that this normal curve is in the middle line here would be the mean, and we have the mean in here. That is the mean to be 70 as it's given. And now we could create 1 standard deviation, 2 standard deviation, 3 standard deviation. So if we are 1 standard deviation away from the mean, that would be 83. 2 standard deviation, you add 83 plus 13, that would be 96. Again, what is that? How did I do the calculation? Is add 70 plus 13 to find what the area would be. That would be 83. That would be 1 standard deviation. Add to that another 13 to find the 2 standard deviation point would be 96. 96. So that would be the 96. Same thing on the negative side. Negative, so 70 minus 13. 70 minus 13. That would be 57. So 57 is somewhere in here. 57. And minus 13, again, to find the minus 2 standard deviation, that would be 44. Yeah, 44. So 44 here. Anyway, so we're trying to target between 60 and 90. So we highlighted the 60. Here's the 60. If you know, this is the 57. So this is the 60. And 96 is here. So that would be the 90 somewhere here. So we highlighted the area. And we know we need to find out this area, the percentage. What would be the percentage of the girls, their weights between 60 and 90? So the first thing that you want to do is find the z-score for both of the values. Z-score for the 60 would be 60 minus 70. Again, we're using this equation z equal to the x minus x bar, which is the average of x divided by the standard deviation or sigma. So 60 minus 70 divided by 13, that would be negative 77. And 90 minus 70 divided by 13, that would be 1.54. And so now the next step is to go to the z-score of table, to the z-score table, and find out what would be the area under the 0.007. And if you go to the table, I have the table in here in front of me just to double check. I know the answer should be 93, but I'm gonna double check 0.77. So you go to the 0.77 minus 0.77, so minus 0.77 here. And then 1, 2, 3, 4, 5, 6, 7. 2, 2, 2, 2, 2206. Yep, that is correct. 2206 and 93.82. I'm gonna go to the Z score and find what would be the percentage under the curve when we have a z-score of 1.54. You go to the positive table and find out 1.5. You go to the first column first and find the value 1.5 and go to the left to find the 0.4. 9382, very good. And now if we create the normal curve and we say, okay, here's the normal curve. From here to here, that would be the 60, and from here, so that would be the 60. From here to here would be the 90. Okay. Okay, so that's the 90 here. So we're trying to find the area here. Again, this is just a rough estimate to give you an idea. Okay, we found out that the area from here to here, I'm going to use a different color. We find the area from here to be 22.06, and from here to here is to be 93.82. So now what we need to do, we need to find the areas between these two. We subtract 93 minus 0.2207, and that will give you 71.76, which means 71.76 of the girls, 71.76 of the girls have weight between 60 and 90 pounds. All right, awesome. There are some questions that I'm gonna leave it here on the screen so you could take it maybe and solve it. And if you have any question, you could send me an email and ask me questions. And here are the answers for you as well, so you could check your answer with what you have. The other topic that I want to talk about it here in this video before I finish, I know this is a long video, but I want to share with you another way to find out the percentile. If the percentile is given and now we need to find the x, it's the opposite. Now what we have in the first calculation we did, we say the value of x, and now we need to find the value, we need to find the percentile, the percentage. Now how about if the percentage given to us, and now we need to find the x. It's similar scenario, but the opposite. So if you find if you given the 60th percentile, we need to find the 60th percentile for a weight of 10-year-old girls, given that the weight is normal distribution with a mean of 70 and standard deviation of 13. So the first thing you want to do is sketch the normal curve, and we sketch the normal curve. We found this is the mean, the 50%, which is the 70 here, then the mean, and the 60th percentile somewhere around here. So what we're trying to find, the how many of the girls that will fit under the 60th percentile. So we did sketch the normal curve, and now let's find the z-score. The z-score is we need to find the area to the left of the 60%. So we need to find the area on the left of the 60. So what we need to do, we need to find using the equation z is equal to the x equal to x minus x average divided by sigma. That would be the equation. But z here is given to us. What we need to do, we need to find x. We need to find the x here. So the x would be equal to, here we did put the equation here, and we need to solve that for x. If you did solve that for x, that would be 73.25. What does that mean? In order to be on the 60th percentile, any girl would like to be in the 60th percentile, should receive a weight, her weight should be 73.25. 73.25. All right, so another example, let's take a look at the example. Find the 10th percentile. We need to find the 10th percentile, this area here, in the normal curve. And we know this is the mean is 0, the standard deviation is 1. Sketch the normal curve. And now what we need to do, all right, let's go back here a little bit just to focus more on this here. I did skip part of it, which is the z-score is 60, right? But what we need to do before we do that, actually, we have to go and find what would be that z-score, what would be that z-score, and how we could find that. We'll have to look into the table. Okay, I'm going to stop sharing this one here and share the other. Okay, so what we need to do, if we need to find the 60th percentile, go to the 0.06. That's what we have z-score. And now you go to the table and look into the body of the table for a value close to 0.06. And if you look here, 0.5, all right, here's 0.6029 and 0.59. So it's between these. So this one would be closer. So 0.25 is the z-score. 0.25 is the z-score. So we have to go back and write down that we have the 0.25 to be the z-score. These are the z-score, and based on the 60 percentile. So the 60 percentile, we went inside the body of the table and we found what the value would be, and we found that value to be 0.25. And now we are ready to apply it. So 0.25 equal to x, this is the variable, minus the average would be 70 divided by 13. And that will give you x to be 73. All right, 73.25. Now, let's continue with this one. If we're trying to find out the 10th percentile for this normal curve, and what you need to do, you need to go into the body of the table and find a value closer to 0.01, and that would be 0.01, and that would be, should be in the negative. So that's 0.1, 0.8, 0.1103. That would be the closer one right here, this number, and that would be 128. So going back and write this down. So 1.28 is the z value, and then you could apply the rest of it. So here's what we did. We find the inside the body, inside the table, inside the body of the table, to find what would be the value that is closer to 0.1, which is closer to 0.10%, and that would be it. All right, here are also some questions that you can practice by yourself, and these are the there should be some answers in here. Yep. So that would be the answers is also given to you. Anyway, that would be the end of the video, but I want to highlight two important links that I use them all the time. And to find the area under the curve, the first link is here. I'm going to click on it. All right, so just make sure that I'm sharing the right. All right, so this link, the first link will find you the normal curve or the area under the curve. So for the example, the girls, the 10-year-old girls with a mean of 70 and standard deviation of 13. And we're trying to find the percentage of the girls between 60 and 90. So that will take you between 60 and 90. That would be 99%. Standard deviation is 13. All right. So if we're trying to find the percentage of the girls between 60 and 90, what you need to do, put the mean, put the standard deviation and 60 and 90 in here. And the other website, which is very similar to this one, same source, and this is again online. Look at the link online, statbook.com/2 calculators/normal curve. This is handy when you have a limited time on an exam and a quiz, and you have to finish quickly. All right, now the other one on the other website. Let's see if just make sure that we're sharing the good website. All right, this website, it's going to give you also the mean and the median. So we're going to do the same example here that we solved for the 10-year-old girls. And we need to find the 60th percentile. And so between standard and the mean is 70. And the standard deviation is 13. And now what we're trying to find, the we're trying to find the so the area that would be if and the area would be the 60th percentile when you go once you go to the z table. Once you go to the z table, you find that z would be 25, and we need to find out the area 0.28, 0.25. All right, so so what we're trying to do, we're trying to find the 60th percentile for this example, the 10-year-old, and this is what you need to put the mean 70, 13. The area is 60 or 0.6, and we need to find the area below the 60th percentile, and that would be 73.294, and this is similar to what we have in the answer. All right, well, that's the end of the video. I'd like to thank you so much for being with me today. I hope you learned something. Please feel free to reach out to me if you have any question. I would love to discuss some of the problems with you. I know this is a long video, but it is really important concept. With that said, I'd like to thank you so much and have a great day.